Thank you. Right, so I would like to talk to you today about Ammonite, and some of you already probably know Ammonite. It's a tool by Lee Howey, which is a shell, an alternative to Bash, but it's also multiple other things. It's also a REPL, and it's also a Scala script runner, and we'll be focusing on the last part. So by Scala script runner, I obviously mean that with Ammonite, this becomes an executable file. So we can just drop any statements in any Scala statements into a file, and the Ammonite will execute them for us, like we were writing Python. Now, this is all well and good, but what are we going to script exactly here? Well, I will be talking about scripting web service APIs, and my primary motivation for this talk is that I have used Ammonite to do exactly that, because we were dealing with multiple repetitive tasks that we needed to do with web service APIs, and I found that Ammonite was an excellent pick to solve this problem. And well, for two reasons primarily. One, web service APIs usually have Java bindings, which means that it's actually possible to script them using Scala. And two, the fact that we will be running HTTP requests means that the JVM startup penalty, which Ammonites incurs on every script run, becomes insignificant. So we get rid of one of the pains of running Ammonite scripts. Right. So I would like to show you how we can, for an example, write a simple script that gets us a status of a GitHub issue. So first, we are going to start by Googling for a library that we can use. We can find something like this, and we happen upon this. So we have some GitHub Connect. I mean, looks fine, and let's just not dive too deep into that. Let's just try to play around with it. So the second step is going to be to find the Maven coordinates for this library, and I actually happen to have them right here. So we can start Ammonite just like that, and this drops us into an actual Scala REPL. Now, if we add this line, then Ammonite is going to include a library for us, and this means that we will be able to actually immediately use what we have just found. All right? So I actually happen to know that trying to use connect would explode because we don't have credentials, so we are going to do connect anonymously. And yeah, everything seems to have worked. So let's see what we can do with this. So if we want to get the status of an issue, then we probably want to first get a repository. Then we probably want to get the issue, let's say 10, because why not? And then we probably want to get state. And yeah, we seem to have found what we were looking for. So let's try to turn this into a script. So a nice trick to use here is to ask Ammonite to give us the history. So now we have the comments that we have run, and we can paste them over here. So we will probably want to wrap this in a function. We want to print this, so returning unit. Okay, we probably want to assign this to a variable. Now we probably want to turn those into parameters to our function. And then we probably want to actually print what we want to say. So we are going to say that the issue number, issue of repo has state it. And we can save this now. And now to actually test if everything went correctly, we can ask Ammonite to include what we have just wrote as a predef. So this means that all of the that we have this definition right here in the REPL. So just to check that everything is okay. Okay, right. So we are still using Scala, and we would like to actually invoke this from the command line. And with Ammonite, this is really easy to do. So all we need to do is first add a shebang line, and then add this simple magic annotation. So now we can just check if everything is runnable, and Ammonite actually tells us that we are missing some arguments. So Ammonite is going to automatically parse the command line arguments based on the parameters of our function. So this means that we can use, actually just pass what we were testing everything with previously. And that's it. This is really all it takes to explore, to find out how to solve a problem using a library and to turn it into a script using Ammonite. So let's take a quick look at the parts of what we did. So the interesting parts of this script are the main annotation and this import $iv thing that we have used. So main methods, as we have seen, are entry points to our script, and essentially they mean that Ammonite will parse the command line parameters for us and will validate that they are, for instance, an int, which is what we want to do, but never want to bother actually writing code for that. The more interesting part is the IV, magic import. So magic import aren't actually imports, but they are special instructions that can only be located at the top of the script file that tell Ammonite what to do before compiling the script. And IV specifically, as we have seen, takes Maven coordinates for a library and tells Ammonite to load it, download it from the internet, and put it on the class path. So, well, one nice thing is that we will automatically get the library downloaded for us. There are no two separate steps, like in, say, if we were trying to script this using Python. But the other interesting part is that we actually reference a library using its specific version. And this is actually quite good. So for an example, we can have an old script that uses an ancient version of the GitHub API, and we can have a new script that uses a normal version of the GitHub API, and those two can coexist and can be run without any problems. Now, again, maybe I'm using the example here, but if we were using Python, then Python scripts refer to libraries by name, and they install the library globally. So if those two libraries were incompatible, then we couldn't actually have those two files coexist together. We would need to use additional tricks to actually be able to run them, where Ammonite just solves this problem for us. Okay. So let's go back to scripting. Let's let's expand what we have just wrote. So say I have this strange urge to also write a script that will give me the title of a GitHub issue. And well, then that script is almost the same as this one, so that obviously means that we need to deduplicate the code, as one does. So let's put the common code in a file called gh. Right. And the common part is going to be, well, it's actually going to be just getting the issue object. So we don't need this, we don't need this, and this seems to be good. And now we will edit the issue state. Now the nice thing that we can do with Ammonite is that we can tell it to watch a script file. And what this does is it will run the script once for us, and then it will wait for further changes to the script file. So now we can try to adjust it. So we now use the gh module, which means that we now have the benefit of being able to write the far simpler version that looks like this. And seems we have a problem. So now the compilation has failed, and Ammonite tells us about that and allows us to fix what we just did. Okay, and now we are done. The script output is the same, but we have it modularized. So let's go back to what we were doing before, which is to actually also print out the issue title, just for completeness. Okay, let's just check that everything here works. Okay, seems to work. Now, so again, let's inspect what we just did. So those are the files that we have defined. And the interesting part is that we, again, used a magic import, this time $file. Well, this file, this import obviously pulls in another file as a module for us to use. And the interesting part about this, well, one, this means that Ammonite allows us to clearly organize our scripts, which again is very useful if we are scripting web APIs, because then we can factor out the common code which is related to dealing with the API, parsing anything that it may have returned, any class definitions. And I have found this a very, very useful way of actually writing a library, because, well, at first we just want to use the web API and do something with it. But over time we can use it more and more, and we will naturally create modules that later on, if necessary, can be turned into a library. Right. So. This is it for the first part of the talk. I hope I have managed to convince you that Ammonite is quite useful, is quite good for this specific use case. And now I would like to be a bit more negative about some things. So also when doing this, I have happened upon some problems with Ammonite that were surprisingly easy to find. So one of the problems is the thing that we see here. So we have a script that just defines a value. We have another script that accesses this value but doesn't import the first script. And we have a main script that first imports the phantom script and then imports the seeker script. Now, well, this probably should not compile, but it does. And the reason why it does, if we try to think about it, is that file imports are too eager in Ammonite. So at first, when we import the phantom module, Ammonite is going to compile it and put it on the class path for us, and then immediately proceed with compiling phantom. So this means that we have this strange object that we didn't really reference. Now this by itself would only be a slight annoyance, but there are further issues like this. So let's go back to those scripts that we have seen before that reference a single library with two different versions. Now what should happen if we include both of those at the same time? So if we do it in the correct order, there is no problem. So if we first import the newer version, then the older one, everything works, compiles, and works fine. But if we first import the old library and then the new one, then the compilation is going to fail because we are still using the old library and it does not define the isOffline method that we need. So again, IV imports are also too eager in Ammonite, and they essentially make Ammonite download a library immediately and lock that version. And this problem that we see here, right here, is easy to fix. However, I actually managed to happen upon this with transitive dependencies. And then it was a bit more of a problem to locate which libraries exactly were conflicting. And a normal build tool would actually solve this for us, but Ammonite sadly does not. And then finally we also have this duplicate script problem. So first we have a grass file that defines a class grass and that defines a method to grow the grass. Then we have a cow file that is located in the born directory, as it can be, that imports the grass module and allows the cow to eat the grass from that module. Now, this seems like it should work if we try to import both of those at the same time and then try to feed the cow the grass. Well, sadly, this doesn't actually work. And the reason why it doesn't work is that Ammonite, again, file imports are too eager. The file is imported immediately as soon as Ammonite sees it, and the Ammonite doesn't really know what name to assign to the file. So this means that we end up compiling the grass twice, and then Scala, the actual Scala compiler, fails because it sees two modules with the two different modules. And fortunately, I think that there might be a really, really good way to think about what Ammonite does, which allows fixing all of those problems. So essentially, if we think about what Ammonite does, then the magic imports part can be seen as build definition that is spread through multiple files that are connected with file imports. And each SC file can be seen as defining an object. So if we think of the problem like that, that means that we essentially reduce compiling Ammonite scripts to just compiling a normal project. And we know how to do that. So if we see multiple library imports, then we can resolve the dependencies as we normally would, which in that case would actually allow us to compile the scripts correctly. If we see modules, then that means that we can actually pick a path, pick a class path, pick a package path for them that is actually common, that is actually the same for all imports. So we would be able to fix all of the problems that we have seen. And the reason why I'm talking about this is that, well, I'm actually part of Martin Oderski's EPFL team, and we have been looking at including Ammonite scripting as part of Dotty or as a tool connected to Dotty. Dotty REPL is already based on Ammonite, so it kind of makes sense to also feature the Ammonite scripting as well. And including with that, I mean, we would try to work on the approach that I have just presented. So what I've shown is, as far as I've gotten, with figuring out how to actually solve all of those problems. So if anyone is interested in this, or if someone would potentially want to do something like that, but for the Ammonite that currently exists right now, then I would be really happy to talk with you and to potentially share and help this move further along. Okay, so this is all that I have. So I would like to end again on a positive note. So I really have enjoyed my experience with Ammonite. It has really helped me, and it will probably help you explore the problem that you have, no matter whether it is doing this specific API scripting thing or anything else. It helps you grow your scripts into libraries, and you should probably try it right now. Well, maybe not right now, but as soon as you can. So, thank you.
Thank you very much. Okay, so we've got two questions. The first one is, can you add a description to the main method arguments?
By description, yes, essentially. There is another annotation which allows doing that. So we can also have a complete help generated for our script.
Okay, thank you. So, and the second question is, does Ammonite use Courier or Ivy for dependency resolution / fetching?
Courier.
Okay. So, yeah, I think that's all of the questions for now. Yes. So, ladies and gentlemen, please thank once again our speaker. Thank you.